So now that I've told you a little bit about endocrine disruptors in general, I'd like to tell you about the poster that I presented at the Florida Lake and Management Society conference. We use mosquito fish as the model organism to look for the presence of endocrine disruptors in our local waterways. So I already mentioned the sources of those endocrine disrupting chemicals, pesticides that we put on our crops and on our yards and even on our bodies, such as DEET, plasticizers with our foods in them, that things that we drink out of. Pharmaceuticals are also medications that we're taking, not necessarily medications that are just being dumped into the water, but metabolized through our bodies, and personal care products. So it's been reported that some women might use 15 different personal care products in a day, which kind of surprises me, but apparently that's fairly common from the women that I know as well. So our model organism is Gambusia. There's two species down here in Southwest Florida. Affinis is the western and Holbrooki is the eastern. They both show this same level of, this same masculinization of the female anal fin. That's the indicator that I'm using in this research. So this is a pregnant female. You can tell because of the big black dot. The female gives live birth. This is the male. This is his gonopodium right here. And that's how he inserts the sperm into the female. And when those eggs get fertilized and mature, she releases live baby fish. This is what her anal fin looks like, and highlighted here are ray 4 and 6. And so in a normal female, the ratio between anal fin ray 4 and 6 is 1.00. What we're seeing in some of our waters is an extension of anal fin ray 4. And you can see that here. You can actually see in the background how these first couple of anal fins are significantly extended beyond anal fin 6. So that's the indicator that we're looking at. Started the research in my community of San Carlos Park that has septic, and every place where you see a colored dot is where I've sampled. I'm going to show you a couple different things on them. So I'll point out the Calusa stretch. The water's coming in this direction. So Calusa and Oriole, Lee and Phlox are one set of samples. You can see those here, the dark green, the centered green, and the lighter one. And another that I'll point out is Cypress. After I started this work and learned a little bit more, I learned about reuse water, and that's also called, it's delivered in pink pipes to golf courses and communities throughout the region. Florida is one of the biggest users of reuse in the country. And all of the pink on this map is showing you where we're putting or using reuse water, reclaimed water from wastewater treatment facilities. So I now sample on 4 different golf courses. I take one sample from the stormwater pond that is obtaining the reuse water directly from the wastewater treatment facility, and then another pond on the golf course that's not getting the reuse water directly. I also sample in a location in Cape Coral that has reuse pipe to every home, but does not have a golf course. And so this is a nice little picture about how reuse is used. And one of my indicators is going to be sucralose, which is Splenda, which has, it's tastes sweet to us, but we don't metabolize it at all. And neither does anything else on the planet. So sucralose that we excrete it just keeps going, and it never goes away. So research goal was to see if we could see differences or relationships between sucralose and masculinized fish, whether or not the sucralose was higher in our septic or reuse communities, and was there a relationship of this 4 to 6 anal fin ratio in these different circumstances as well. I've collected over fish and water from over 40 different locations. Sucralose data was done at Florida International University, and our own Ernesto Lasso de la Vega at Lee County Hyacinth Control did the nutrient data for us. And my students and I collected the fish in the water and did the imaging. So this first picture is showing you the 4:6 anal fin ratio, either in the golf course effluent lake, which is the golf course receiving the lake receiving the water directly from the wastewater treatment facility, in comparison to a reuse lake. And then if you look over here, I've taken this bar for reuse and compared it to the septic. And you can see that the average is quite low, quite a bit lower, but I've got a lot of points here on the y-axis that are pretty high. So I think I've got some data cleaning up to do still. Let me move over this way a little bit more and up and show you now this one. If I look at the 4:6 ratio, the golf course effluent, again, the lake that's getting the wastewater treatment directly, compared to the reuse, and again, compared to the septic. So we've still got and these are thousands of fish in my septic community and probably hundreds in the reuse. So there's other analyses that I need to do as well. And then this is our sucralose data. So I mentioned that the sucralose is never digested. So there it is in golf course effluents, reuse significantly less, and septic even less than that. Now, another neat feature that we can see from these data that I've collected over time is temporal data. So the blue boxes that you see are a sample that I took about a month and a half after Hurricane Irma hit us. And Hurricane Irma did quite a job in our community of San Carlos Park and really brought the water up high. So you can see that on that Calusa strand, which is these three locations, my sucralose concentration was over 6,000 at this location, but then dropped pretty significantly by May of 23 or May 23rd of 2018. And by September, all of those other locations are less than 1,000 nanograms per liter. But if you compare that to the Cypress strand, you can see Hurricane Irma, and afterward, where these ones drop so low, these are staying like higher than 3,000, somewhere between 3 and 6,000 nanograms per liter. So there's very different things happening in one strand of this community compared to the other. And then another indicator that shows you and is tracking well with the sucralose is the total phosphorus. And so this dotted line is 0.1 milligrams per liter, which is the standard for total phosphorus in surface water. And you can see that it was, kind of elevated here, went up quite a bit for Hurricane Irma and then dropped, but in all circumstances was below the standard. Where if you look over here on the Cypress strand, where we had that much higher sucralose concentration, we had a peak in 2 of the locations where after Hurricane Irma, 2 went up and 1 went down quite a bit. I'm not sure about any of what's causing this, but they were all above the standard except for a couple of times. So that's what I found so far. I've still got quite a few students that have, almost 80 students have done this research with me, and got a master's program at FGCU now. So hoping that I might be able to get some graduate students that have more time to be able to put forward with this and find out what's going on. And I hope you found this useful. Thanks a lot. Email me with any questions, ndemers@fgcu.edu. Take care.